So try and get the first page done. Make sure that one person's reading, that everyone's on the same problem as you go, that we're not like leaving anyone behind. I recommend you're going to have to graph a couple of things. I recommend like color coordinating your equation to your graph so that you can easily relate them. How come you're writing? You guys haven't even read yet. Busted. All right, ready, set, someone read, go. Remind me at the end, I can give your tests back so we can start the retake process if anyone wants to do that. So what does X represent? Does X represent the days? Yes. Yeah, so if you have the mug club, you bring it every time you buy. Yeah. So what, how did you write it? Yeah, that's that. That's gonna take that's gonna take one off of the number of coffees you bought. Like the 2.25 minus 1 like would be in parentheses if you're gonna do it that way. Does that make sense? Yes. I mean, yeah. Yeah, but if she's writing her steps down, yeah, that. Yeah. Don't forget the one part where it does say to graph. Yeah, you have to graph them both. Graph each of the equations. Gosh. Yeah, but each. Wait, okay. So we just have to graph every equation. So you go to 2.25 on Well, I don't know. I don't know.
I knew that there was no y intercept, so I started at 0. And then I just did a slope of 2.25, and I did 2 points and negative y.
Okay, you could also, if that's not computing, 2.25 is hard as a slope because it's a decimal, right? A couple different options that you could have. Okay, so if 1 cup of coffee is 2.25, how much would, like you could figure out how much 4 cups of coffee is? Do you see why I picked 4? 6 times 0.25 times 4 is 1. Does that make sense? So you could make that point 4, 9. Does that make sense? You also could think of 2.25 as a fraction and use it as a slope. Where are we in this process? Are you talking about, did you graph already? Okay, what do you need in order to graph a line? Do you need a y-intercept?
Not necessarily.
Not necessarily. Do you need a slope? Low key, yes, but like not really, right? Can't you just use 2 points?
Yes, ma'am.
Okay, so since we are dealing in the first quadrant, a y-intercept would be good, right? So for the blue one, the y-intercept, if you buy 0 cups of coffee, you're paying $0, right? Otherwise, bad business. So if you wanted to pick another point, you could just plug in an x value. Do you see what I'm saying? Now, but if we're gonna do that, let's think about which point we picked. If we pick 1, then we're gonna have to do 1, 2.25, and that's like tricky on here. Agreed? So what would be a good x value to plug in for that? That could give us a nice number. Okay, 0.25, yeah. 4, right? Because 0.25 times 4 is 1. 4 quarters is $1, right? $1 plus 2 times 4 is 8. So this would be 4, 9. And then we could draw our line through that.
You're on 10.
That's what, dang. Yeah, that's what I did the first time too. Thanks for looking out. Another way we could have think of that is, what? Did I do something wrong? Slopes, we're uncomfortable with slopes when they're decimals. It's like the only time we want fractions is slopes, right? Would you agree that's the only time that we're like, yes, I really want a fraction? So could we turn the 2.25 into a fraction? Without a calculator. Oh dear. 0.25 is 1/4, right? So 9 over 4x. That gets us in the same spot. So does that help you then graph the second one? If you haven't already graphed it. What was your equation for the second one? Do you want me to give you a couple minutes to finish the page and then we'll come back together? All right. Are you guys finished? Struggling? Do you need help?
2 minus 2,
That
2.25 minus 1 is 1.5.
Which is the one giant cost.
Yes, 2.25 minus 1 is 1. I'm sick. She said never mind. So I was right. Yeah.
Did you guys answer? Make sure you answer all the questions if you can.
It says no. So
Yes.
is
Yes.
it worth it?
Yep.
It's worth it when
Not until you have
Yeah.
at the very end.
Until you have first grade costs.
Yeah. So yeah, do it
What was
in
the
different
second
ones.
iteration?
Does anybody want to come graph their line on my iPad or answer any of the questions on my iPad? Well, that's right. Excuse me, too. See, it's not even hers. Come on.
Well, 2.2 used for the second.
You taught me about windows.
Yes,
I'll teach you
Write
it up there.
I just went and I counted and I went,
You're not. Oh, 1, 2, like what's the step? 1.25.
oh, I got an 8.
Don't ever say that to me again.
Will you do that one in purple?
Yeah.
Yes, 1 cup of coffee, that's 1 cross.
Isn't my apple pencil nice even though it's...
It is, but this is like, is this, oh, it is like actual apple. It's like squared. I like that I can actually like grip it.
Will you graph the line?
Yeah. Starts at 8 and then goes to...
And then I'm gonna let you stop after you graph it.
Okay.
What?
4 to that, and then that goes to, is it here? 18 right here.
Wait, no way. Yes, and then have to go by 8 Sorry, I was reading.
All right. Is this what your graph looks like?
Yes.
Okay. What's happening with these 2 lines? You can sit down. Thank you, Matt.
Okay.
Everyone, thank Madeline. That was beautiful. Okay. How did you go about attacking this next question? Yeah. Okay, so, but for this question, it just says, if she plans on purchasing 6 cups of coffee, which one should she join the mug club? So I want to know how, I don't want to know, like, what the answer is. I want to know how you went about attacking this question, deciding, there's no wrong answers. I just will honestly, I can see what Madeline did. Madeline was going to plug, I'm going to assume, plug 6 into both equations and see which number is lower because we want to save money, right? Did anybody do that differently? Did anybody look at the graph before they went to that? Okay, look at the graph before you go to that and see if you can figure out why I'm asking you to do that. Yeah.
Because if there's a graph there, you see it, it just takes out an entire extra step.
Okay, but what, like, how can, but I have to know how to use the graph to be able to take out that entire extra step, right? How could I use the graph to be able to answer that question? You guys aren't listening to me, are you? Yeah.
Because, like, the first one is increasing, like, more, so but it's like, when you go to 6, it's lower on the y-axis
Uh-huh.
than the other one, so they're, like, cheaper.
Yeah, okay, and so she used some really cool math words. I'm gonna use some, like, just other words. But hers were awesome. Okay, at x equals 6, my purple line is above my blue line. Which one am I paying more money for? Purple. What did my purple represent?
No, for
Purple was not the mug club for me. Right? No, purple was the mug club.
Yeah.
So the mug club was more expensive at 6 cups than without it. Do I need to know what the amount was? No. All I want to know is which one should I buy the mug club if I'm only going to get 6 cups of coffee? The answer is no. Algebraically, would have got the same thing, no problem with it, but also being able to just, if the graph isn't asking you to do extra math, don't have to do extra math, right? Okay, when do they cost the same? At 8 cups, how'd you know that? So you use the graph to determine, okay, the y is representing the total cost. So after 8 cups, when x equals 8, that is when the total cost is the same. Did anybody do that differently? That's the way that's a great way when you have a visual. Yeah, did you do algebraically? Yeah. Totally fine, because sometimes we don't trust graphs, right? Sometimes we are like, I don't know, I want to go through. So you did it algebraically and got the point 8, 18. You just found x.
Yeah.
So you got x equals 8, right? She looked at the graph and got x equals 8. So we feel confident in that, right? These two lines intersected at one point. How many cups of coffee was I supposed to ask? Oh, what is the total cost? The total cost is $18, because that's the y value. Okay, so how many cups of coffee would you need to purchase in order to make the mug club a better deal?
We said 9 cups.
Yeah, 9, 8 or more cups, but yeah, 9 in this case. Or more than 8 cups, not 8 or more, sorry. Just assuming that we can buy a half a cup, right? Probably can't, but. Okay, go ahead and talk about roaster coffee. Make your, on this graph, bring down the one that is for the mug club. Like, graph that line again on this graph for the mug club.
For the other one?
For the other one, yeah. It's. Which makes sense, right? Because you're starting by a paying amount.
They're currently running a mug club advertising it says buy your cup for $10 and get half off all cups of coffee. I know. It's one cup of coffee is $10
Bless you. What's half of 2? 10. Half of 15.
And then I'm so sorry to do this, but.
Oh, I'm sorry. I'm not sure. I apologize.
that what we got for that one?
Yeah.
How does this compare to the other graph or the other equation? I'm sorry.
Starts at 10.
Okay. So it has a y-intercept of 10. How else does it compare or contrast?
They're parallel.
How come? How do you know by looking at the equation? Do you know? They have the same slope, right? And when two lines have the same slope, Tegan gets it again. Geometry 2 times 1 day, right? Have you guys have done that, I'm sure. Yeah. They have the same slope, so the lines will be parallel, right? Would anyone ever go to Roaster Mug? Why not? You're always going to have paid $2 more, right? Because your original mug was more expensive. And their regular coffee is more expensive. Oh, we're going to assume that they like heavy in the system. So when they realize, I answered that in the wrong spot, didn't I? Oh, yeah, no. So when would you want to use never, because the line let's say the y values. So the total cost spent is always higher. What happens if Rooster realizes their mistake and they say join the mug club now for $8 and get half off all cups of coffee? What does that do to their equation? Does their equation change? So if they're joining, so this was our line right here, right? Originally they're joining for $8. They're not changing the cost per cup. They're actually just taking that line and moving it on down, aren't they? They're moving it down too. So what happens there? They end up the same line. So would it matter which place you went in that case? No. This is not necessarily on topic of what we're learning, but as a marketing person, do you think it would be wiser to say, join our mug club for $8 and get $1 off a cup of coffee, or join our mug club for $8 and get half off your cup of coffee? As a consumer, which one are you like, oh, doesn't half off sound like a way better deal to you, even though it ends up being the same thing because their coffee just starts more expensive? Okay, so when they ended up being the same line, every cup of coffee cost the same. Every point on that line was a solution of the system, right? Does that make sense? For this first one, there was one solution, and it was where the lines intersect. Caroline found it algebraically. Tegan found it graphically. The lines intersected at one point. She found that point. When they had a different starting price for the mug, who said? Audrey said, oh, the lines are parallel because they have the same slope. And then when we drew them, we realized, oh, they never intersect. Those two totals will never be the same. The lines are parallel, so there's no solution to that system. And then the last case when they are the same line. So I made this little chart that's gonna go over, it's kind of gonna recap all of that. So if you have a system of linear equations, so we're not gonna finish this today, so I think we'll get as far as we can. I think I put the homework due for Thursday anyways, so. I'm gonna kind of try and keep my colors organized. So one option is no solution. That was when the mugs cost different amounts, but the cost per cup of coffee was the same, right? So in an equation, what does that look like? What did the mugs on our graph, what did the mugs represent? The cost of the mugs, what did they represent on our graphs? The cost of just the mug, yeah. Yeah, it was the y-intercept. It was 8 and then 2 and then 10. So when we have, and then what the cost per cup of coffee, what was that? It was the slope, and it was the same. So if we have a system, I'm going to kind of go out of this in a weird way. I was going to change the order, but I didn't feel like it. If they have the same slope, sorry, that's supposed to be this purple. I'm on a different iPad. And then their y-intercepts were different. Then the system would have no solution. So if we had this system, y equals, I'm going to start with these in different formats so that we can look at them in all the different forms. This is written in slope-intercept form, right? Y equals mx plus b. It's easy to identify the slope of that first line. Would you agree? The slope of that first line is -2/3. And so because it's easy to identify the slope, the y-intercept would also be or the y-intercept is also easy to identify. The y-intercept is 4. Okay, I'm not going to graph this perfectly just because for time. A line with a negative slope. Show me with your arms. Okay, wait. Let's pretend like it's going to be on here and I'm behind you. So I'm going to be behind you. Show me with your arms. Is it going to go this way or this way on my paper? Yeah, it's going to go like this, right? Negative slope. The y-intercept is 4. Is that going to lie above the x-axis or below? Above. So I don't know exactly what it's looked like, but I can say that I think it's going to look something like that. That's a reasonable sketch. Not probably the best, but at least it's something. Okay, so then to graph this, I could find the x and y intercepts and draw that line, but I'm really interested in knowing what the slope is because that helps me determine if the lines are parallel. How do I find the slope of that line? Can we get y by itself? So 3y is negative 2x plus 4. So y is equal to negative 2x, or negative 2 over 3x plus 4/3, right? When we divide that 3, we divide everything by 3. Okay. The slope of my blue line is negative 2/3. What's the y-intercept? Just give me, you can give it to me as a fraction. It doesn't have to be 4/3. The slope of my pink line was negative 2/3. The y-intercept was 4. Okay, when I go to graph that negative 2/3 x plus 4/3, it should be the same as my pink line. The slope should be the same direction. Should it lie above the pink line or below the pink line? And how can we figure that out? Talk to your pots. How come? Because the y-intercept is smaller. The y-intercept is 1 1/3, which is smaller than 4. So this is what that graph would look like, right? You're like, you're telling me stuff I already know. So if two lines have the same slope and a different y-intercept, there is no solution to their system. And their lines will be parallel. So part of what I'm going to be asking you to do is to tell me how many solutions there are and explain using characteristics of the graph and tell me what the graph would look like. To solve this equation, how would you want to go? I just want to show you what it looks like algebraically as well. How do you want to solve this system? We learned yesterday elimination and substitution, right? Which one you want to do? It's kind of set up for substitution where we could take that pink and plug it into this y. Was that right? Okay, we go ahead and we distribute, so 2x, 3 times negative 2/3 x. That becomes negative 2x, 3 times 4. Okay, so we have 2x minus 2x. What happens there? Those cancel out. So don't we get 12 equals 4? Caroline's got a puzzled face. Does 12 equal 4? Madeline. Why did I say Caroline? Is that your sister's name? Yeah. Does 12 equal 4? Not here, not today, not tomorrow. 12 doesn't equal 4. Now, if it said 12x equaled 4, would that be okay? 12x is allowed to equal 4 because there's a variable. That would give us x equals 4 over 12. But the number 12 just does not equal the number 4. It's not true. So if we get to the end, our variables are gone, and we get an untrue statement, that's how algebraically that we know that there is no solution. Do you want to stop? Okay, we'll finish this tomorrow. Oh, you're having so much fun.